we're now ready to move on to the calculation of these values. That is, what percentage of this sample is gravel, sand, silt, and clay. It's helpful if I remind myself what is typically considered gravel, sand, and silt and clay. So to give you a better view, I'm going to move this up slightly, okay, and I'll move it down as necessary so that we can see what I'll be working on right here. Okay. So the percent gravel refers to the material that is retained up to and including the number 4 sieve. So there are a couple ways you can do this. We know that up to and including the number 4 sieve, we have 0 plus 0 plus 0 plus 0.59 grams of material. So to calculate this amount of gravel, we could do 0.59 grams in this case, right? It's the sum of all the retained up to and including the number 4 and divided by the total, which is this value here. That gives us approximately 0.1% of gravel. I'm going to remind you again, I did not include the percent sign because I'm telling you this is going to be in percent. So make sure that you don't give me an opportunity to steal marks away from you by doing so. Now, another way that you could do this too is as follows. Since we're looking at everything that's included up to and including the number 4 sieve, we could go to the number 4 sieve and see how much of this is passing percentage-wise. The percent retained is simply 100% minus that value. So another way is 100% minus 99.9% gives us that value. Okay, so there are a couple of ways that you can do to figure out the percent gravel. Again, the percent gravel is the percent of the material that is included, that is retained up to and including the number 4 sieve. Great. Let's move on to sand. The percent sand is the percent of this sample that is passing the number 4 but retained by the number 200. Okay, so for the percent gravel it was this here. For the percent sand it's this here. So again, a couple ways that you can do it. The simplest one is to take the sum of these numbers and divide it by the total sample. If you do that, you get 98.5. I encourage you to give that a try to see if you get the same number. If you don't, there's perhaps a mistake that you're going through, and it's good now to identify it. So give it a try. In terms of silt and clay, this is what you get in the pan. Voila. So the way to do silt and clay in our case is 7.47 divided by the total, and that gives us 1.4% approximately. Okay, and by approximately I mean based on one significant digit. To check whether or not you've done these calculations correctly, when you do this number plus that number plus that number, you should get 100%. Not 99.9, not 100.1, 100%. If you don't, then maybe you need to work on the number of significant digits or your approximation of the rounding that you've used. Okay, so that's a good trick. Make sure that this number plus that number plus that number works out to 100%. We're almost done, ladies and gents. we're now ready to move on to filling in these two items. So what you're going to need in this case is your textbook and the data you obtained from here. Ready? Good. So from your textbook, what you want to do is find the Unified Classification System tables that are on page 20 and 21, figure point 2, figure point 3. So what we're looking for in this case is this symbol classification that can tell us basically what our sample is based on the Unified Classification System of soils. So what we're going to do then is we're going to work our way starting with figure 2, possibly moving on to figure 3 or figure 4, and we're going to work our way from top to bottom and then from left to right. Okay. So we're going to start with top here. Is our sample a coarse grained soil? So that is, does more than half of the material finer than 3-inch sieve, larger than 200 sieve? So does our sample pass, does more than 50% of our sample pass the 3-inch sieve and is retained by the 200 sieve? So the answer is certainly 50% of the sample is retained within this range. Okay. What we get is that only 1.4% of the sample passes the 200 sieve. That means 98.6% of the sample is retained in that range. Okay, so let's move to the next column. This column asks you, is more than half of the sample larger than a number 4 sieve? So does more than 50% of the sample, is it retained in a number 4 sieve or above? So we go over here, we find that 99.9 passes this sample. So that means that less than 1% is retained at the number 4 or above. Another way to look at it is, this question is asking you, does your gravel comprise of 50% or so? And the answer is no. You can see here, gravel is not 50% or so. So this is not the right row, we move down. Now, this says ditto and ditto, which means the same as above, the same as above. We already found that these two were not correct, so we need to move down to the next one. We know that this item here is the same as that, so we're okay. Now there's a different condition here. Does more than half of your sample comprise a material that is smaller than a number 4? That is, does more than 50% of the material pass the number 4? So is this number here at number 4, is that number bigger than 50%? In our case it's 99.9%, so yes, this is true. Move on to the next. Does less than 5% of the material pass the number 2 sieve? So if we go to the number 200 sieve, that's 1.4%. That's less than 5%, so this is true as well. Okay? Less than 5% of the material passes the 200 sieve. We can move on to the next. Okay, we have two choices now. Over here, we have this choice and this choice. Let's start with the top one. We would have this choice here. If Cu is greater than 6 and Cz, that's not actually Cz, it's a misprint, it should be Cc, is between 1 and 3. So let's go to our calculations of Cu. Is Cu greater than 6? No. Is Cc between 1 and 3? No. That means this is not the right row. We move down to the next one. Notice what it says here. not meeting both of these two criteria. So that means that we're in the right row. So we've satisfied this condition, this condition, this condition, and this condition. This is what we identified here for the group symbol, that is the Unified Classification System for soils. Okay, so it's SP right there. Now, what does this actually mean? This means that it's a poorly graded sand and gravelly sands with little or no fines. So what I'm looking for you to identify here is the soil description, which is poorly graded sands and gravelly sands with little or no fines. So you can notice that my pencil is starting to get a little dull here. It's not very precise and clear. I expect that what you submit to me will be much clearer in format. Now, one thing that you could do is transfer it to a blank sheet in pen, or you could fill in the blank Excel spreadsheet that I've posted for you, and then you know for a fact that I will be able to read it, because you're letting the computer write in everything for you, and there's no ambiguity to what the numbers say. I'm okay if when it comes to writing the description, you write the first portion of it, like I did here. Maybe you don't have enough room. Alternatively, you could also make this 2 rows. Then what you would do is you would print this whole thing out and hand it in to me. This fits on 1 page. I expect you to make it fit on 1 page as follows. Also, don't forget to identify yourself. You'll notice that here I've put for you space for you to identify your name and your student number. That way I can tell who you are. It also would not hurt if you were to identify your group here as well. That way I know who your group mates were. Okay? Alright, so the final thing that you need to do then is to identify whether or not this sample is actually a granular A sample. Now granted, the one that I'm showing you right here is just a sample I graded through a sieve analysis. The one you're going to be getting might give you a different curve with different D values, different coefficients, different percentage values right here. How do you identify whether or not this is a granular A sample? You would go under assignment 1 to the provincial standard for granular A, B, M, and other subgrade material. And this here is the law in Ontario that says specifically how you identify granular A material and other granulars. So this here, you're going to find somewhere in here a table that tells you how to identify granular A. And specifically, it's based on how much material percentage-wise passes a specific size of sieve. So you notice that there are some ranges here, and I'm sure that when you did your construction materials 1 and 2 labs for sieve analysis, you worked out what these ranges were. What they'll come out to be is some boundaries on the left and right hand side of this line, and if this line is within those boundaries, then you do have a granular A material. If this line is outside of those boundaries, your material is not granular A. So that's very important. Okay? Make sure that you identify whether or not this is granular A material and that you show me how you did it. Okay? Just saying yes it is or no it isn't is not sufficient. It's the equivalent of not answering that question. Is this granular A material? What you want to do is show me how you got that answer. Great. I'm not going to keep you any longer. I'll give you a chance to go over this lab again with the sample data to see if you can get the same results as I did. Do not hesitate to ask any questions if you have some. Check your CSI or your Blackboard announcements page to see when this document is due, when this lab is due. I look forward to speaking with you if you have any questions. Thank you.